Hello, everyone. Today we are going to study 6.2 trigonometric function. Okay, so I think everyone knows what's trigonometric function. So before we talk about the integral, so before we talk about the integrals, so let's first review some identities. The first one is sine squared x plus cosine squared x equals to 1. The second one is 1 plus tangent squared x is secant squared x. 3 is sine squared x is half 1 minus cosine 2x. 4 cosine x squared is half 1 plus cosine 2x. So I hope you can remember these formulas or identities. Okay. So if you do more problems, you can memorize it. It's not that hard. Okay. So now let's compute the integral. Now let's study trigonometric integrals. Okay. So this is our goal today. Study this. Okay. So our first example is like this. So compute the indefinite integral cosine power to 3 x dx. You can find the antiderivative of cosine power to 3x. Okay. So if you look at this problem, the first question is that, okay, how do I get started? I think many students ask me, oh, how do you get started in my office hour before? So for this kind of problem, first, you need some experience. After you accumulate some experience, finally, oh, you know how to do it. You just first study the method. Okay, so if you just use U substitution or you use the integration by parts we studied last week, it may not work. You may try. Okay, so here, how do we do this problem? So we will use the identities. Here we reviewed today. So how do we do this? It's a common trick. So first, we rewrite this term as cosine power to x and cosine x, right? So for the first term, we use the first identity. Above, this is 1 minus sine squared and cosine x. So, and then, so we have cosine power to 3 dx is integral 1 minus sine x squared and cosine x dx. So, and then what do we do next? So here is the cosine x, right? So here we set, this is a trick. We said we use the u substitution. U is sine x. And then we have du is cosine x dx. So that's why we choose u to be sine x because of this term, you know. And then by u substitution, we have this is 1 minus sine x squared cosine x dx. Put the, you know, regard this term as a whole. So we have this is 1 minus sine, u squared and du, right? So, and then let's continue to calculate this. This is 1 du minus u squared du. The first term is u, right? The second term is 1/3 u cubic plus a constancy. Don't forget that. So you cannot just leave this as the final answer because u doesn't appear in this problem, right? So we have to, you know, substitute u by the sine x. So we have this term is sine x minus 1/3 sine cubic x plus c. So this is the final solution. Okay. Okay, that's this problem. So sometimes if you are worried about it, if you get the correct solution, what do? You may check the derivative of sine x minus 1/3 sine x plus c. You compute the derivative. This should be cosine cubic x. If this is not right, it means that your computation, you know, for the antiderivative is wrong. Okay, you don't have to check. You know, sometimes in case you made a mistake, you check it and to make sure. Okay, my computation is totally right. Okay, so that's this problem. Okay, for this problem, I can give you some, you know, variants like this. So if the problem like this, cosine handle 2n plus 1 x dx or sine 2n plus 1 x dx, means that the power is an odd number, not even. Okay, so the method is the same, and then we separable 2nx, or we say we separate one less dx, and we separate 2nx and sine x dx. And in this step, we use u is cosine x. We use u is sine x. And also we use the formula, the identity. And also we use sine x squared plus cosine x is 1. Okay. So we will get this is 1 minus, you know, I think I made a mistake. Anyway, here, this should be sine x. This should be sine x. This should be cosine x. And then this is u squared and power to m, and you know, this is du. Okay, and then this is 1 minus, you know, u squared power to m And du here we have a minus. Why we have a minus? Because du is negative sine x dx. This is because du is negative sine x dx. Anyway, I hope you don't have to memorize the formula here. So because all this two formula, when you're doing a problem, you can compute it directly. That's why I'm saying you have to know this strategy. It's kind of, whenever there is a problem like this, you just follow this method and you can figure it out. Anyway, that's just my suggestion. You may say, okay, I just want to memorize it. Okay, that's fine. If you memorize it, is enough good? It's good enough? Okay. So this is our first example. So I hope you can study more from the remark, for the power is the odd, right? So let's look at our second problem or second example. So our second example is like this. So this is find sine 5x cosine x dx. Okay, it's kind of complicated, right? So for this, how do we do it? The first power is 5, the second power is 2, right? So let's get started. Because here, sine power to 5, we rewrite this as this form. What our goal is separate one sine x. Probably many of you will ask me, why do you do this? It's a trick, right? After we show something later, you will say, okay, after you look at the whole problem, and then you will say why we do this. So this is sine x power to 4 cosine x. You separate one sine x, and then what can we do? We can write the first term is x power to x cosine x sine x. So we write the first term as 1 minus cosine square x square cosine x square sine x. So here we use the identity. This is 1. So we have sine power to 5x cosine power to x dx is 1 minus cosine x square and cosine x square sine x. And then what do we do? So we set u is, we do the u substitution, okay, is cosine x. So we have this term is 1 minus u, and then we have the u is negative sine x dx, right? So we have this is this and the u square and the negative du. So let's continue to simplify the integral. This is u power to 4 minus 2 u squared plus 1 and the u squared du. So, and then let's continue to, simplify. This is power to 6 minus u to power to 4 plus u squared and du. And then the antiderivative is don't forget the lective here. Okay, that's very important. So this is 1/7 u power to 7 minus 2/5 power to 5 plus 1/3 u power to 3 and plus the constant c. So like what I said, don't forget the c here, and you cannot leave u here. You have to, write your u as cosine x. This is negative 1/7 cosine power to 7 plus 2/5 cosine power to 5x minus 1/3 cosine power to 3x plus the constancy. Okay. So I'll write a remark. How do we do this kind of problem? Remark or variance. So, for example, the problem is kind of sine 2n plus 1 x cosine 2m x dx. So means that for one function, sine x or cosine x, the power is odd. Another one, the power is even. The method is the same as the previous one. How? So we write this is sine 2n x cosine 2mx. And then we separate sine x dx. And then we use 1 plus is equals to sine x squared plus cosine x squared. And also we set u is cosine x. So we will get the formula this. So the reason that I didn't finish this because I don't need to remember, I don't require you to remember the formulas. You have to study this method. Okay. So, or another variant, this is cosine 2n plus 1x sine 2m x dx. Means that for cosine, the power is 2x or is odd. Is an odd number. The method is the same. You separate 2m x cosine 2n x. We separate 1 cosine x dx. Okay, and then we use 1 is equal to sine x plus cosine x squared, and u is sine x. You will get something. Okay, you will get something. So that's this kind of problem. So this is example 2. Okay. Yeah, that's good. So let's look at our example 3. So example 3, the problem is okay, sine x squared dx. So how do you do this? So first, if you do this, you may try use substitution integration by parts. You try that, you may feel, okay, it's so hard to use substitution and the integration by parts. So how do we do this kind of problem? We first use the identity. So this is half 1 minus cosine 2x. So this, after you do you use this identity. We have this is half 1 minus cosine 2x dx, right? So let's simplify. This is half minus half cosine 2x, right? So this is dx, right? So, and then let's continue. This is half dx minus half cosine 2x dx, right? So for the first term, you know, the antiderivative is this. For the second term, what's the antiderivative? Right? This term. What's the antiderivative for this? So here you set u is 2x and du is 2dx. So we get this is 1 over half and u, right? du and half, right? Because dx is half du. So we get this minus 1 over 4 u du. So this is this minus, yeah. So we get this is here we do the substitution. This should be cosine u du, right? Here should be cosine u du. So this is 1 over 4 sine u plus c. This is 1 over x minus 1 over 4 and sine 2x plus c. So that's this problem. Okay, so let's look at the variant for this. So the problem could be like this: sine 2nx or cosine 2nx dx. So means that the power is an even number, right? The method is the same. You write this as sine x squared power to n, right? For this, you write this is cosine power to x, right? Power to n dx, right? And then you use the identity. So this is half 1 minus cosine 2x power to n dx, right? This is the same plus 2x power to n. And then you can, simplify this. And also you simplify this. Okay. In general, when you are doing this problem, the power will not be very high. Okay. You may say, okay, if n is 2, for example, you compute this, you get a cosine 2x power to 2, right? You have to repeat to use this formula again. Okay, so that's enough. Okay, we will not give you a problem. The power is very, very high. Okay, so let's look at one more example. Okay, let me fail. That's why I didn't compute this out. You may fail. Okay, so let's look at one more example. Example 4. So this example is, okay. So this is sine power to 4x dx. The first step is we use sine. We write this as sine square and square. So this is 1 over cosine x squared power to 4. So we compute this. This is 1 over 4. And 1 minus 2 cosine x squared plus cosine, sorry. I made a mistake here. Cosine 2x, right? Cosine 2x, let's get 1 minus 2 cosine 2x plus cosine x. This is 1 minus half cosine 2x plus 1 over 4 cosine 2x. Right. So let's compute this. This is sine power to 4 dx. By this identity, we have this minus half, right, cosine 2x plus 1 over 4, right? Sorry, I jumped. I should not jump. So plus this cosine 2x and dx, right? So let's compute this. This is 1 over 4 dx minus 1 over 2 or half cosine 2x dx plus 1 over 4 cosine squared 2x dx, right? So we continue to compute the first term. The antiderivative is 1 over this. The second term, you have, I hope you have to know this. The antiderivative is 1 is half and half cosine 2x and plus 1 over 4 cosine 2x dx. Right. But here we have cosine squared 2x. So here we have to repeat to use this. Cosine squared 2x is half 1 plus cosine 4x. So we get 1 over x, 1 over 4x minus 1 over 4 cosine 2x. Right. Right? I think it's right, yeah. Cosine 2x. No, I think I mistake. This is sine 2x. So this is sine 2x. This is sine, okay. Sine and plus 1 over 4, 1 over 8, 1 plus cosine 4x dx. So let's compute this 1 over 4 sine 2x plus 1 over 8. The antiderivative of this is x. The cosine this is plus 1 over 4 and sine 4x plus c. So finally we get the antiderivative, is 1 over 4x plus 1 over 8x minus 1 over 4 sine 2x plus 1 over 32 sine 4x plus c. We can simplify the first two terms. So this is 3 over 8 times x, 1 over 4 sine 2x, and 1 over 32 sine 4x plus c. Now I think you can understand why I didn't, simplify this, compute it out. You can feel if the number n is bigger, the power of, every term, the power for this term and this term will be both great, right? And then for example, the power is greater, you have to repeat to use the identities. Try to, can make the power to be 1 and increase the number inside the sign. Like here, you can say, you cancel the power, right? And then the number inside the cosine is double, right? Anyway, so that's this problem. Okay, let's continue. So next kind of problem is example 5. So example 5 is tangential power to x and secant power to 4 dx. Okay. I know if you are first time to, if you are the first time to do this kind of problem, it should be feel, hard. That's normal. Okay, it's the same for me. Okay, just study the method. How do I do this kind of problem? So if a problem like this, the trick is the same. Tangent power to x, secant power to 4x. Do it like this. Keep the tangent x, secant, and you separate 1 secant x. So you may say, why do we do this? It should be a reason, right? Why do we do this? The reason is that after we do this, we have tangent power to x. We replace this by 1 plus tangent x. This is a formula, just remember it, Here we use secant x is 1 plus tangent x. Like this, we used this. So this is tangent x. So after we do this, so how do we compute? This is tangent power to x, secant power to 4 dx. This is tangent power to x, 1 plus tangent power to 2x, and we have secant x dx. So how do we continue? Here there is a trick, because we use the u substitution. This is tangent x, and then we have du is secant x dx. Why do we say the u is tangent? Because we know du is this, that's why we do this. So it's kind of, this is the essential part for you to do a problem like this. Okay, so and then let's continue to computation. We use the u substitution here. We have u power to 6, 1 plus u power to 6, and du. So if you compared this problem with the previous problems, the trick is the same. Oh, you play some basic trigonometric function identity, and then you do a substitution. Finally, you get a polynomial, right? For the polynomial, I think everyone knows how to find the antiderivative. So let's simplify, use the distribution rule, right? Plus this and du. So the antiderivative is 1/7 u power to 7 plus 1/8 to 8 plus c. So we replace u by tangent x plus 1/8 tangent 8 x plus c. Okay. So Barry. So the problem, if like this, so is tangent. This is 2mx or secant. Okay, 2nx dx. The method is the same. You separate tangent 2mx secant you know, 2n. Of course, this number should be positive. N is greater than 1. Otherwise, if N is 0, you know, that's totally different, right? Okay. So 2n minus 2x, and you separate out secant x squared dx. So, and then we use 1 plus tangent x squared is secant x squared, and set u is tangent x. You play the same trick as the example 6. Okay, example 6. This is example 6. Oh, example 5, sorry. Right? Play the same trick as example 5. So here, both power are even numbers. So let's look at one new type of problem. So this is like this. This is example 6. So this is tangent power to 5x and secant power to 7x dx. So you can say for this integrand, the power to tangent and secant are both other number, right? You may try the previous techniques. I'm not sure it works or not. Anyway, but this kind of problem has one technique, you know, you may study. So how do we do this? The trick is like this. Okay, so we write, okay, let's write it out. 5x secant 7x. So how do we do it? So let's write it in this form. Tangent x secant x. We separate this out. This is tangent power to 4, secant power to 6. It's kind of, we do this. We separate this term out from the whole term. So, and then what do we do? So let's continue. Okay. How do we do it? So let's do it. Here, we just write, this is tangent 5x secant x. So we write it is tangent power to 4, secant power to 6, and tangent x secant x dx. So what do we do here? So we set u as secant x. So that's why we do this. Why? Because we know du is tangent x secant x dx. So by this, we have this, you know, we know tangent x squared is secant x squared minus 1, right? So we get this is 1 u squared minus 1 complete squared, u power to 6 and du, right? The same trick, right? We get a polynomial power to 4 minus 2u squared plus 1 times 6 power to u 6. So we get a u power to 10 minus 2 u power to 8 plus u power to 6. So we get 11 u 11 minus 2 9 u 11 plus 1 over 7 u 7 plus say here. So this is secant 11x minus 2 over 9 secant 9x plus 1 over 7 secant 7 plus. So that's this problem. So let's look at the variant. So this is tangent 2n plus 1 x secant 2m plus 1 x dx. For this, the method is the same. 2nx secant 2mx. You separate one tangent x and secant x together, and then you set u is secant x, tangent x is u squared minus 1. Anyway, the method is like this. You just follow this method, and then that's okay, I think. I think that's the normal problem for this part. Okay, you should, study this kind of examples, and then remember all the variant. This is one variant, another variant. So it's kind of for every problem, we have, a variant correspondingly. So here we have a variant, right? Yeah, here we have a variant. So anyway, so I think that's all the normal problem for this part. What happened to my Zoom? I don't know.